Today we're going to start about electricity. This is Dr. Ahmad Al Faris. Assalamu alaikum wa rahmatullahi wa barakatuh. Look here, when we talk about electricity and magnetism, which is the fourth block in the IGCSE Cambridge syllabus, it's a very important topic and block. It has a lot of questions about it. First of all, we are going to talk about electrostatic, okay, in this worksheet. Then we'll talk about electric currents. So electrostatic, from the word it's static, that means it's at rest. Electrons at rest, or charges are at rest. To realize this more, what do we have? We know that we have the smallest element for any molecule is what? Is the atom. Inside the atom, we have something called the nucleus, and we have shells around it, okay? Shells or orbits around it. In the nucleus, what do we have? We have something called protons, and something we call it what? Neutrons. Okay, and around these shells, okay, there's electrons orbiting around the nucleus. Exactly, electrons. Okay, so as all of us knows that protons have positive charge, and neutrons, they have a neutral charge, okay, and the neutrons, they are negative. And it's very hard, okay, to lose or gain protons. So what are the free charges that the atom can lose or gain? It's not inside the nucleus, it's outside the nucleus, which is what? The electrons. These are the free what? Charges. These are the free what? Charges, okay? Good. So to understand, we are talking about charges here. We are talking about movement of electrons. And every time they ask about how this object becomes charged or how there is current flows, if you mention electrons, you get a mark. If you mention that electrons are negative, maybe you get 2 marks. It depends on the mark scheme. So you have to realize that you have to mention electrons, which have a negative charge. Okay. So now, when we talk about charges here, we have 2 types of charge. We have positive charges and what? Negative charges. Yes, shukran Muhammad wa Marwan wa Layth. They are give me correct answers. Thank you. I hope that all of you can give me the answer. We have negative charge and what? Positive charge. Bravo, ya Marwan. Thank you. And I'm sorry, I wrote positive. Positive. Okay, we have positive charge and a negative what? Charges. Okay. Marwan said by gaining electrons which have a negative charge. Yes, exactly. So that means when the object, okay, has a negative charge, that means the number of protons is less than number of what? Electrons. When it's positive, that means the number of protons is more than number of what? Electrons. Because actually, usually all the objects, they are neutral. They are what? Neutral. They don't have a charge. The number of protons and number of electrons, they are what? Equal. So how the object becomes positively charged or negatively charged? As what? As Marwan said, the positive charge by losing electrons, okay, it becomes positive by losing electrons, okay, and it's become negative charge by gaining what? By gaining what? Electrons, okay. Tamam. So now, as we all know that we have what? We have 2 types of electrical forces between charges. We have 2 types of electrical forces between charges. What are these 2 types of electrical forces? As who can tell me? Yes, bravo. A lot of you send me correct answer. We have what? Between charges. What do we have? Electrical force between charges. What do we call it? في ناس عم بيبعتوا answers بس مش اللي أنا بدي إياه. What is the type of electrical force between charges? We have 2 types of electrical force between charges. We have something called attraction, and something else called what? What do we call it? Yes, exactly, repulsion. Bravo, repulsion. Okay, so when we talk about attraction, we are talking about the unlike poles. What do I mean by unlike poles? Unlike charges. Unlike charges, okay? Unlike, that means we are talking about positive and a negative. okay, not north and south. North and south is magnetic, okay? We are talking about positive and negative. Huh? I wrote it here. I didn't write north and south. Actually, the magnetic force and the electric force do not affect each other directly, okay? Later, we are going to talk about that in details, okay? So the unlike charges, positive and negative, they will attract, but the like charges, they will what? Repel, like when we talk about negative and negative, or what? Positive and what? And positive, okay? Tamam? Good. Okay, you can take screenshot or you can write this information on what? On the worksheet directly, because I'm going down now. تمام. أشوف بس هالشغلة. حازم محمد سيدرا يوسف. Okay, good. Now, next. Now, in electricity, we have types of materials. What are the types of materials here? When we divide the type of materials according to electricity, we have several types of materials. Okay, we have metals, they are conductors, bravo. We have conductors, and what do we have? Exactly, insulators. شكرا للشباب اللي عم بتجاوب ما شاء الله. Insulators, okay? And of course, we have something between, excellent Muhammad, we have something between, which is what? Semiconductors. So what do I mean by conductors? Usually conductors, they have many free electrons. They have what? Many free what? Electrons. Like whom? Like whom? Who can give me examples for materials that have many free electrons? Like what? Gold, bravo, copper, tamam. What else? Gold, copper, what else? Steel, excellent. Okay. Copper, I put coupled. Okay. Copper, okay, what else? بس ما في خلاص هدول همي. We have many, okay? We have many. All these are metals, exactly. Bravo. All these are metals. Silver, okay? So all metals, they have what? Many free electrons. So that's why they are good conductors, because they transfer electricity through them. So why they are do that? Because they allow current or charges, okay? Allow charges to pass easily, to pass through them easily. Okay? Now, the opposite of this is what? Is the insulators. They don't have many free electrons. Few what? Free electrons. Who can give me examples like what? Like what do we have materials that they are insulators? Give me examples. Yes, like carbon is not necessarily, it's carbon actually it's a semiconductor, okay? It depends on the type of carbon. Rubber, bravo, wood, exactly, glass, what else? Cotton, the clothes that we wear. Mercury, it's a conductor actually. Paper, it's a type of wood. It's what? Water, if it tap water, it's a good conductor because it has ions. If it pure water, H2O, it's what? It's not a conductor, it's an insulator. So let's neglect water, okay? So we can write here, as you told me, cotton, wood, okay, wool, bravo, glass, okay? All the things that approximately we wear it or we put it as insulator for thermal energy, not also electricity, okay? Semiconductor, they like graphite or silicon, okay? Bravo, graphite or silicon, excellent, okay? They what? Graphite or what? Silicon or other materials, okay? Tamam. What they are? Actually, they are insulators, and they become conductors at certain what conditions. Okay, so they are insulators, okay, become conductors at certain conditions. Okay, good. Take a screenshot if you please, or write this information. Graphite conduct electricity when it has an aqueous solution. Aqueous solution. What do you mean by aqueous solution? Okay, it depends on the instructions and it depends on the temperature of it. Yes, exactly.
Sir, aqueous means that it's in water, right?
Yes, if you put any solution of water, that means we have ions, and because we have ions, positive and negative ions in the water, we have dissolved solution. Okay, this solution that it can transfer ions by its ions, the electricity or the charges, so it's a good conductor. Yes, dissolved water. Yes, bravo. Okay, طيب, تمام. So now the most important question of this first topic of this first lesson: how we can make the object charge. Charging an object can be by several ways. First one, by rubbing. Second one, by conduction. Okay, and they didn't ask about it many years ago because it's a part of understanding the charge or the transferring electricity. And number three, induction, that they bring questions from while to while about it. So these three methods, how we can make the object charge: by rubbing, by conduction, by what? Induction. Yes. Thank you, Abdurrahman. Yes. Rubbing creates static electricity. That's how we are talking about. Yes, about how we can make an object charge. For example, if I bring this pen with another plastic pen, and both of them, they are plastic and plastic, okay, same type of plastic, and I rub them like this, none of them becomes charged. But if I rub this pen of plastic with wool, okay, our cloth, or with my hair, okay, different insulators, one becomes positive and one becomes negative. Why this one becomes positive, for example? Who can tell me why this one, the pen, becomes positive and the hair, for example, becomes negative?
Because the pen contains metals?
No, because actually doesn't contain. Okay, the pen is a plastic. Why? Exactly. Shukran. Shukran, Abdurrahman, كمان. Some materials, they have the ability to lose electrons. Other materials, they have the ability to what? To gain electrons. Thank you, Sadra. Yes. So this ability to lose or to gain electrons, they have different for insulators. Even if they don't have free electrons, but they have the ability to lose. Other materials, they have the ability to what? To gain. So when I want to make a charge by rubbing, I will not bring a metal. Why? If I bring a steel rod, okay, and this plastic, and I rub them, the steel rod will never be charged. Or if I rub it with my hair. Why? Because it's a good conductor. Whenever the instant it lose or gain electrons, okay, the rod, okay, if for example this is a steel and I rub it with my hair, whenever it gains charge, because it's a good conductor, the charge will leak from it to my hand and return back to my hair, and or return back to the hair exactly in the same moment. So the charge cannot stay on it because it's a conductor. So rubbing happens between two different insulators. One has the ability to lose electrons, and the other has the ability to what? To gain electrons. Like when I bring a balloon, rubber, and I rub it with my hair, it will be charged. How I can check? I put it on the wall. It will stick with the wall. Why? Because it has, as some of you told me now, it has electrostatic, and this electrostatic make attraction with the wall, so stick. Okay, or you can, if you have a long hair, especially the girls here, if they have long hair and they rub it with the hair and they move the balloon away, the hair will attract to the balloon. That means the hair has a charge and the balloon has another charge, so they will attract to each other. So if I want to write about rubbing, how the process happened, and they bring questions from while to while about it, 3 marks on it, what I'm going to say: when two different insulators are rubbed, friction force, the force that makes the electrons move, friction force makes the electrons moves from the one which has the ability to lose, which has the ability to lose electrons, the ability to lose electrons, and becomes what? Positive or negative? If it loses electrons, becomes what? Exactly, positive. Bravo. To the other one, to the other that has the ability to what? To lose or to gain? Bravo. That has the ability to gain electrons. And what happens to it? It becomes positive and negative. And becomes, exactly, and becomes negative. So that's how rubbing happened. Okay? Good? Excellent. طيب يا أستاذ، لما الأول يصير positive, for example صار positive 5. The second one, ده بيصير negative how much? Negative 3, negative 4, negative how much? If the first object was what? Positive 5. The second one will become how much? Exactly, negative 5. Why? Because the first one lose some number of electrons, the other one gained the same number of electrons. And we cannot create electrons by holding the hand like this, or we can't destroy the electrons. So when one object loses electrons, the other one gains it. So the same charge we have here, the same magnitude, but opposite sign, one positive and one negative. Yes, because positive 5 plus negative 5, it will be 0. So the charge will be, the resultant charge, it's supposed to be neutral. Okay, so when two different neutral insulators, I forget to write the word neutral, neutral insulators are rubbed, okay, friction force makes makes the electrons moves from one which has the ability to lose electrons, and the other has the ability to gain what? To gain electrons, and becomes what? Negative. So if I bring aponite, types of plastic, two rods of aponite that they are negative charge, and I brought them close to each other, I can see that this one, if it hang, it will move away. Why it will move away? Because they have same charge, so they repel from each other. But if I have aponite and glass, and both of them they are charged, one negative and one positive, I can see that there will be attraction between them because they have unlike charges. So if I rub fur with rubber, okay, for example, the rubber becomes negative and the fur becomes positive. For example, if the rubber was -2, the fur will become what? +2. أستاذ أنا شايف كثير positive. ليه كاتب +2? I'm not talking +2 electrons. I'm talking about +2, something called coulomb, the charge of the coulomb. We are going to study it in a few seconds now. Okay, good. The same thing if we do for glass rod with silk. If we rub them, the silk becomes negative and the glass becomes positive. How do we know which one is positive and which one is negative? They will tell you. They will give you a hint from where to where the electrons move, or they will say that one becomes positive or one becomes negative. It's not necessarily to memorize which one is positive and which one is negative. They will not ask about that. Okay? تمام? Okay. طيب. Now, charge is conserved. This is the answer of what we said. What we was saying here. We said that same number of electrons lost by an object, it is gained by another. So if, so by rubbing, if one is +5, the other becomes what? negative what? Negative 5. Okay.